Hello, everyone. How is your day? Good? Having fun? Perfect. So, my name is Tamir. I'm the engineering lead for the security team in Abdom. And today, I'm about to talk with you about how malware can abuse accessibility service in Android to perform credential stuffing attacks. So, before we start with all the fancy words like credential stuffing and malwares, let me tell you a little story. One day, while I was coding and working, a colleague of mine sent me a Teams message, and he said, "Hey man, you must click on this link," followed by a suspicious link. So, you know, being a security guy, I didn't push the link, and I took a screenshot of this message and sent to my Abdom Teams chat. And then, 5 minutes later, Danny's computer, my colleague, he sent a message. His computer got blocked because of this message. So he came to my desk and he wanted to throw a chair on me because it couldn't work. And then I got him a lunch and we sat down and clicked the link. The link showed a video in Twitter of concerned mobile app user showing a very interesting thing happened in this app. So let's watch the video together. Let me click play. So basically what we can see here is a mobile payment app and where you can transfer money to contacts. And what he attempts to do is to transfer money from his balance. He selects $1. He selects his contact and is validating that it's $1 to this contact. He selects to transfer from his balance an authentication method, and then he clicks pay. So now he points out to the navigation bar and take a look, closer look, and you will see a color change. So once it's done, it asks for the PIN code and it cancels it, and you can see that the contact has changed and the amount has changed. So a normal user would basically just type the PIN code and transfer the money, and he wouldn't know that it happened. So this brings us to today's topic. Yeah, it's done. How many of you understood what happened? Oh, okay, Jack. Perfect. So, before we go to talk about the malware, let's talk about the basic and boring stuff. Credential stuffing. How many people here are using their passwords? Yeah. Come on, don't be shy. I know you use your Instagram password to your bank account, and of course everyone here. Because we are lazy, we are humans. And basically, credential stuffing composed of two parts. The first part is you need to obtain a list containing username and password combinations. They are called also combo lists. And then you use those combo lists to perform attempts in multiple applications, login attempts, and I can guarantee you that you will get a match. Once you get a match, you can sell the account and get a lot of money. Combo lists, you can easily get them on Telegram. Open your Telegram now, search for combo lists. You will see plenty of free combo lists. And if you are willing to pay, you will get even a better combo list. And then you can search for combo tools, which are tools that you can use to automate logins to multiple apps. And once you do that, you can sell it for Bitcoins and be a multimillionaire. Great, so there are two types of credential stuffing attacks. The first is centralized credential stuffings. It composed mainly on a server farm of Android emulator devices, and they're just running attempts to log in. This type of attack has two problems. The first one, in today's world, most Android devices, most Android apps has emulator detection, and this attack will fail. And the second one, a simple anti-bot measure, such as limiting the number of connections from a single IP, will block this. This is good for, simple server, not a banking account. And then we go to the decentralized credential stuffing. So this is basically a botnet. You use a victim devices, which attempts to log in, and without the user know about this. It's very powerful, but it's very hard to do because you need to infect the device, and it makes the attacker works very hard. And this is the attack we're going to focus in this lecture. Okay, it's dead. Perfect. Okay, so now we're going to talk about the ATS. The ATS is a fancy name for malware that just transfer funds automatically from your device to another account without the user knowing about this. And this kind of malware is a very popular attack. In the last few years, we have seen many attacks. One popular variant is the xenomorph one, this one. And in the last year, it got, I think, 50 million accounts in 1 year for multiple banks. It's insane. Basically what it does, it composes of 4 parts. You need to infect the device with a Trojan. This can be easily done by using social engineering. Hey, you got this link, press, install, you don't know about this. And you can think about creative stuff. I have some ideas, you can come later, I will tell you how. And then you need, then the malware needs to connect to its command and control server and get some scripts to run on the device. Once it gets its back from the server, it starts running those attacks. And then it can steal your money, your accounts, your photos, your data, anything. Let's continue. So a simple attack for the malware is using overlay. It's much simpler than what we saw in the video. The video had a very interesting type of malware. Basic attack is just showing the user a simple overlay. If you look here, this is what the actually screen below the overlay. The user thinks he's transferred small money to his friend, and what basically happens, he transferred to Lev, which is my colleague, a lot of money, and you can see that it's drained the account for the poor user. Any questions so far? Perfect, you're a good audience. Accessibility service. It's very easy to implement an ATS malware using accessibility service, and this is what we are going to do in this presentation. Who knows what is an accessibility service? Perfect, can you tell me? Yeah, correct. So basically accessibility service is helping users with disabilities to use Android systems and devices. It's basically a background service that receives callbacks from the system once we have an accessibility event. For example, if the user touches the application and the content has changed, we will get a window content change event. And if you want to implement such a service, you need to extend this service and implement the abstract methods. Once you do that, you can also get the capability to query the content of the active window. And we will use those, we will implement such a service in a moment. So it's going to be now. And we're going to implement a malware, a simple malware, and this is only for education purposes. No one opens a computer and tries to take the code. And we will going to do that, and I'm going to show you how to use the DCS attack, the decentralized credential stuffing. So do not write this at home. First, we are going to declare the service, and we're going to declare the service with the necessary accessibility service permission, which is the bind accessibility service. You declare this in the Android manifest file. I'm sure you're familiar with the Android manifest, right? We are in an Android conference, not iOS. Okay, perfect. And now we need to implement the service. As I told you, you need to extend the accessibility service and implement the abstract methods. So basically what I'm doing here, and this is important, I'm setting the flags to get all the events from all the apps in the device. So every accessibility event that will be triggered will be caught in this service. Yeah, you're going to implement the malware. Don't. Good. So now, funny thing in Android, and this is why it's easy, you can launch any app from your application without any additional permission. All you have to do is to find the package name and the main activity, and then launch it from your app. Simple as that. This is from the app's manifest, and this is our service. Simple. And we are going to focus on a sample app I found on GitHub. Looks nice like Nike. And we are going to try to find the login page and try credential stuffing. And to do so, we need to implement the onAccessibility event. This is the handler for the accessibility event that is fired from the system. This is an important thing to say. You need to implement the malware based on the homework you do on the app. You need to take the app and investigate it before you produce the malware. You can use, once you get the accessibility event, you can use the calling get root in activity window. This is the root node of the window, which is basically a tree of all the content in the device. And you can see that we can get all the nodes in the tree. It's some buttons, the scroll, the text, everything can be done from this tree. And then, if you can see this ugly function, I implemented the recursion function that all it does is to iterate over the tree and return a list containing all the nodes in the active window. This is a simple function that will help us to get what we need. And what we need is to get fast to the login screen. And now we can do that. So I took the application and I checked what is the best and fastest way to get into the login page. And surprisingly, is by clicking on the cart button, which is identified by its resource name cartbtn. Funny. And then I'm iterating over the list and checking if it equals to the cart button. And then all I need to do is click on the button. Simple as that. And then we are in the login screen. So what you need to understand here is that what we did is a powerful tool. Every action we've made triggered an activity and an accessibility event. We launched the app, we got a window change content event, then we handled this event to click on the login on the cart button and to get into the login page. From the content changed event we received after this perform action, we can manipulate again the system and enter the login details, and so on. This is called accessibility event chaining. This is a very powerful tool and scary tool as well. So all we have to do now is to find the text for username and password, fill in the login details. Same thing you need to do. Take the root tree, get the nodes, find the nodes you want, and all is left to do is to click on the login button. Simple as that. So, congratulations, you have a malware for a specific application that can do a login. And when I tested it at home, you can do around 5 to 7 login per second. So imagine you have 10 minutes of login attempts on one device. This is insane. But since it's something that was to specific application, you can make it generic. You can do all the code we've done, you can do it generic. You can open a command and control server, which is the DCS attack. And then the malware can send to this server a list of applications that is installed on the device, and it can get back a script of what to do. It can get the package, the paths to login, and the combo list to run. And you can see all the commands it can do. No. Getting the list of what? Sorry? You can query. You have, yeah, query all packages. It's a permission. Okay, yeah, it's an important note. If you want to query all the apps in the system, you need to have the permission in the manifest of the malware that is installed and has all the permission to query all the apps. One drawback of this malware is that the user can see what we have done. And we don't want to do that. So can we hide it? Of course we can. This is, this is very easy. There are some ways to hide the malware. We can use the orientation sensor manager. And the main idea is that when the user flips his phone down, we will run the malware. And when it flips it back up, we'll press the home screen. So it's very easy, right? We need to implement a sensor event listener, get the accelerometer, and then check. If the gravity is below, just run the malware. If the Z is plus, close the app. And you can enhance this thing by adding a wake lock permission. The wake lock permission gives you, he's laughing, giving you an option to keep the screen open, and when the user just put this phone down, you get a lot of time to run your credential stuffing. For example, if I did it for today, I took a lunch and I forgot to lock my screen, and I put my phone down, and it was like 20 minutes lunch, I think. And it's a lot of time to run credential stuffing. You can get a lot of attempts. And not coffee, yeah, of course. And another way to hide what we do is to use something that, like we saw in the video, you can show an overlay. When the user attempts to log in, you can show him a loading screen and delay the user in 2-3 seconds. What the malware did before is very complicated because he showed overlay, but what it did is to go back to the sending money screen, change the amount, change the contact, and then go back to the same screen. This is why you saw also the black navigation bar. Very complicated malware. This is simple. And once you delay the user in 2-3 seconds, you can get 10 attempts, 20 attempts. And this is simple. All you have to do is to follow the steps, and you can get a lot of accounts. Of course, just for learning purposes, you cannot sell these accounts. It's very easy. Before we continue, any questions? Nothing. Perfect. So let's talk a bit about AppDom. AppDom is where I work at, and our goal is to protect all mobile apps application, or mobile applications, sorry, Android and iOS. We support both platforms. And this is done very easily. All you have to do is to take the binary, the APK or the AAB, upload it to our fancy platform. You can have a demo afterwards with Jack right here. And you can select any security feature you want, such as protecting the malware we've just seen, and wait maximum 3 minutes, and you get the same application with another security level. And basically go to the store, protected. I suggest if you want to come to a demo, we will show you it's in runtime, and you can get also a free t-shirt, cool t-shirt. And that's it. Any questions? It's actually, you need to do social engineering. For example, you can create a text-to-speech service, but it's actually a malware. It can do some text-to-speech, but it's a malware. You can think about a creative way to create the malware, to hide the malware. The malware we've just seen, the Xenomorph, is installed via, I think, you take an APK from Google, like Photoshop, Act Photoshop, and it can install another APK when you when you launch the application. So you have an Act Photoshop, but you also install the service that can take your money, and you don't know about it. Hi.
Thanks for the speech. And I've seen you already partially answered the question. I probably missed in the beginning how user actually, like, okay, he can install the application accidentally by clicking some link someone has shared with him, but he will also give like very dangerous permissions to the app, and a user will see that he's giving these permissions, and wouldn't it be too strange?
Usually, most of the applications today are required to support accessibility services. So when I install an app, I work as a security guy, and I don't care about the permission. I need to see the app, so I just click allow. I don't even read the permission. And I'm a security guy, so it's pretty funny. And so you will get the permission, and you will get the users. You don't need to worry about that. There are limited people that actually see what you do and check what you do.
So why would an attacker even go to essentially UI optimization to test login details? Are apps commonly are the actual endpoints for HTTP calls actually protected that well to see that the request needs to come from an actual Android app? Because I think it would be way easier to just do the login HTTP request directly without you going through all this UI optimization.
I use a bank account. It's located in my country that doesn't have a web, just an application. So imagine that it's one bank, you have plenty. And you can do that also for mobile gaming. If you want a user with a lot of money, just try to get them the user, and it's easy as that.
Okay, thank you.
More questions? Yeah. Feel free to ask. We have like 10 more minutes, and you can talk about everything. You can even talk with me about obfuscation, whatever you like. I can answer it.
Thank you for the talk. My question would be, are there ways as developers we can protect our apps from these malwares?
Yes, you can buy Appdom. We can protect
it. Without subscribing to a third-party solution?
I can't share with you why and how we do that, how we protect. It took us 3 months to think about a protection for such malwares and such attacks. But I can give you like a friendly advice, okay? You can query the service, ask for its name. Basically, if I will going to go to write a malware, I will call myself Google text-to-speech. It's fine. Google will allow that. It's fine. But you can check for malicious actions. You can see what the malware, what the service does, what the service requests. You have the option to check if you have overlay on the device. And then if your app detects that you have an overlay, you can block the service. Sometimes it gives you false positive, but it depends on your goals. If you develop a banking application, I will take the risk by blocking the overlay even if I have false positives. I don't want to take any chance that someone will hack the banks. Depends on you, but you need to research a bit more. I can't tell you the secrets.
Thank you.
Any more questions?
Maybe a question from a different perspective. Pretending I'm just a user, I'm not a developer.
Can you speak a bit? Yeah.
Pretending I'm just a user, I'm not a developer, and I don't need to pretend that because I'm not a developer. What would you recommend to take my action on to look for? What like the bind accessibility service permission or the system overlay to see if an app has something that doesn't belong there? Be more careful.
Usually you can query your device using ADB to check which apps has specific permissions. In Android, I think 13 and above. In Samsung, I think it's from Android 10, you can see which app has bind accessibility services in your mobile device. Then you can see if you see some suspicious apps, and you can remove them from the device.
My question was rather, I see a new app and I think I like this app and I want to install it.
You want to install
it. What permissions does it have? I mentioned 2 permissions already for that, which I would look for, like why does an app need to query all installed applications if it's just a calculator, for example?
So when you go to the Google Play today, before you install the app, you have a list of all the permission the app requests. Okay, we are talking about a legit user that installed the app from the Google Play. Most malwares are installed from APKs that you download from the web, and then the user needs to query the application using a reverse engineering tool, which permission it has. But when you have them on the Google Play, today I think most developers must mention why they need the accessibility service and get, and this is improvement from Android 14, I think. Google can give you like a blue mark that you are a good accessibility service and not just a fake one. And you can see it before you install the app.
And are there specific permissions you would say to take special care for, to look at?
The bind accessibility service permission is the basic accessibility permission. There is nothing that you can block. It's simple permission. Query all apps is a suspicious permission. I don't think you should install an app that can query your device.
A launcher.
A launcher, okay. But that's it, right?
Thank you.
You're welcome. Any more questions? Perfect. If you want to talk with me, I'm at the Abdon booth, and you can send me any email if you have questions or follow-ups, and you can add me on LinkedIn if you want. I'm a nice guy, probably. That's it. Thank you.